It's all you.
Okay. Hello everyone, I'm Leonor Lee and I'm currently a senior at Cary Academy.
My name is Jalissa Hobbs and I am a junior at Clinton High School.
My name is Eli Freed and I'm a junior at Chapel Hill High School.
And as part of Summer Ventures, we completed research which is for this assessment of stream recovery or not, and that is a former copper mine in Ashe County. So in this presentation, we'll first give you a background on Ornaw Mine, what happened there and why it is the way it is today. We'll then give you our hypothesis and purpose statement, which is what we focused on and why, as well as our methods, which is how we collected our data for macroinvertebrates and chemistry analysis. We'll then give you our results and analysis, which is our data and how we base our conclusions on that, and we'll end off with our acknowledgements. So Ornaw Mine is a former copper mine that was in operation between 1857 and 1962, and they extracted copper, gold, and silver using froth flotation devices as well as cyanide leaching processes. And these processes led to the buildup of waste materials known as tailings. And these tailings are what currently contaminate the water surrounding the area.
So some background on what the pollutants are. So one major type of pollutant is acid mine drainage, which is a mixture of acidic compounds such as sulfuric acid, which can account for the yellow tint as seen in the picture and the low pH values that were recorded. Another pollutant is toxic elements such as lead and cadmium, which are heavy metals and make it much harder for any organisms to thrive in the stream.
So in order to help these streams that have been negatively impacted by outside factors such as Ornaw, the EPA developed Superfund. And the Superfund is a project in which the government is willing to spend millions of dollars into the remediation of streams that are infected with chemical pollutants. And so they did a removal action in 2008 at Ornaw, and they officially classified Ornaw as a Superfund site in 2009. And some of the actions have been excavating sediment from a downstream basin, constructing a channel to divert the stormwater from around the tailings pile, redistributing the face of the bank, and filling 4 ponds around the perimeter of the pile. And they also did a remedial investigation on September of 2010 and plan to do a final remedy on Ornaw in May of 2020.
So the purpose of this experiment was to determine how Ornaw and Peak Creek are recovering through macroinvertebrate collection and water chemistry data, and through this determine how effective the EPA Superfund was in cleaning up these 2 sites. So our hypothesis in words is the Ornaw branch has and will continue to show a slow and gradual recovery due to the restoration by the EPA.
So to collect water chemistry data, we use various probes connected to a Vernier LabQuest, and we stuck the probes into the water and we get an immediate reading for pH, temperature, conductivity, dissolved oxygen, and various minerals.
And for our macroinvertebrate collection, we use the Qual4 method, and this method has 4 aspects, which is visual, the use of the DNet, use of the kick stain, and finding submerged twigs and leaf pads. And for further analyzation, we use an Olympus microscope in our lab, and we use an economist key in order to find the order and family of our macroinvertebrate. And this is an example of the economist key that we use in the lab. And as you can see, if you go down the flow chart, you'll get your order. As you continuously go down, you'll find your family. And these are students using the Olympus microscope in order to analyze the macroinvertebrate further. And this is students with daughter tuberty using the kick stain in order to find the macroinvertebrate off of the net.
So at each site, we collected a sample of water in a Snapple bottle, and we took the sample of water into the lab and used the microwave digestion system to just get rid of any particles that could interfere with the analysis. We then took this water sample into this inductively coupled plasma atomic emission spectrometer, and the water goes to this tube into this nebulizer, and what happens there is that the water turns into a spray of atoms. And as that happens, the spray of atoms causes the electrons to get excited and jump up orbitals, and as it goes into this excited state, it wants to fall down to a more stable state. So as it falls, the orbitals, once again, it releases photons, and these photons can be analyzed for their wavelength, as well as the number of the photons can be used to figure out the concentration of the specific element. And these are the sites that we analyzed. Here's where Ornaw Mine is in North Carolina, and as you can see down there is the Ornaw retention pond, and that's where the conditions are the worst. It's where the water is completely orange. It drains down through Ornaw Branch into Peak Creek, and we took data from Peak Creek downstream and upstream of Ornaw Branch to kind of compare. And then we took data from Peak Creek near New River.
So our first graph shows family richness, which is the number of different types of macroinvertebrates that were found at each location. So Peak Creek upstream, there were 18 families found. Peak Creek downstream, there were 22 families found, which is significant because it shows that the contaminants aren't having a huge impact downstream in Peak Creek. At Ornaw Branch, much closer to the pollutants, there's only 5 found. And finally, at the holding pond, the very closest at the source, there's only 1 family found. And these pie charts depict macroinvertebrate tolerance, and a lower tolerance means better stream quality. So in Peak Creek upstream of Ornob, 50% are very low tolerance. In the downstream, that drops to 40%, but the number of moderately tolerant macroinvertebrates doubles, which shows that there is some impact downstream. At the Ornob branch, 40% are high tolerance, which shows you it's very polluted. And at the retention pond, 100% are high, and that was only one family found, and that was the Chronomedy fly larva, as shown. And that's a picture of the holding pond. And this graph shows pH readings from 2005 to 2019. So at Peak Creek downstream, there's a slight upward trend with a lower value in 2019, although these can be impacted by rain and other things. At Ornob Branch, there's an upward trend, and since the scale is logarithmic, that is a notable improvement. And finally, upstream of Ornob Branch, it's showing relatively stable values of pH.
So we measure conductivity in microsiemens per centimeter, and to give some context for this data, any conductivity below 50 is considered good and healthy. So at Ornob Retention Pond, you can see we got a measurement of 1,338, and that is twice as high as sewage effluent. So that shows just how toxic it is there. Along Ornob Branch, we got 703, which is better, but still not very healthy. However, at Peak Creek downstream and upstream of Ornob Branch, we got 36 and 32. So that means that Peak Creek is healthy, both upstream and downstream. So this is showing that EPA efforts have been effective because there's kind of a separation between Peak Creek and Ornob Branch in terms of the conditions.
We also ran tests for ions, which we tested for calcium, nitrate, and chloride ions. And as you can see, as you move upstream from Stream X into Ornob headwater, the levels increase gradually. And as you can also see, calcium appeared more frequently than chloride and nitrate ions. And this is likely due to the limestone that was added by the EPA in order to neutralize these pH levels within these streams.
So this is a graph of EPT, which stands for Ephemeroptera, Plecoptera, and Trichoptera. And that stands for mayflies, stoneflies, and caddisflies. And these are the three most sensitive macroinvertebrates. So the number and amount of these macroinvertebrates can be translated into a rating for how healthy the river and the water is. So the rating goes from 1 to 5, with 1 being poor and 5 being excellent. However, don't take these ratings literally because they're a little bit inflated, but you can use them to see the general trend of how the water has been improving. As you can see, in 1990 it was 1, which is poor, and from 2003 to 2013 it was also 1, but then from 2017 to 2019, in the past 3 years, it's gotten a rating of 5. So to give some context, once again, the final remedy was kind of planned and chosen around 2010, so you can see that it was directly correlating with what happened there. So from the previous graph, you can see, and this data was from Peak Creek, downstream of Ornob Branch. So Peak Creek has improved greatly, and it's now like a trout stream where people can fish. So it's no longer a danger to drinking water and well water surrounding it.
We also did tests on toxic elements within these streams, and we tested for iron, copper, lead, chromium, cadmium, and arsenic. And this line, this red line right here, represents the NCDQ threshold for healthy streams. And if anything above this line is unhealthy streams. So as you can see, Ornob Holding Pond is increasingly high above this NCDQ threshold. And this is likely due to the Ornob Holding Pond being closest to the acid mine drainage and getting most of those contaminants.
So summing this up, the lead, iron, and copper levels were over the NCDEQ levels in 2019. And while several element concentrations did go down, iron, cadmium, and lead went up even further in the Ornob Branch. So in conclusion, Ornob Branch has shown signs of improvement, but the mine is obviously still causing detrimental contamination to the stream and preventing any sensitive organisms from living there. Peak Creek, on the other hand, has made a full recovery and is suitable for sensitive species, and this shows that the EPA Superfund has been effective and was worth the money to remove the toxins and contain them to Ornob Branch.
And lastly, we'd just like to thank Dr. Tuberty, Mr. Ruff, and Mr. Taylor for mentoring us and helping us through the whole process, as well as Dr. Babiak for helping us with the chemical analysis, as well as just Summer Ventures as a whole for giving us this opportunity to speak here. One thing that Dr. Tuberty, Mr. Ruff, and Mr. Taylor told us was that they have been analyzing Ornob Branch for years, and they have seen firsthand how much it has improved. They remember sticking their hand in the water and having the hair on their hand come off. That was how severe it was back then. So it has improved greatly, but right before their eyes. And one thing Dr. Tuberty always told us is that we are all downstream. So even though this is in Ashe County, it may seem far away, those are our headwaters. So that's affecting us down here as well. So yeah. Any questions?
Promote how important it is to protect these headwaters, because ultimately, if it does get bad enough, we will be affected.
So as someone that lives in that region, it's affecting me every day, because I'm from Watauga County, which is right next door to Ashe County. You were talking about dollars earlier, and it seems like when it comes to politics and anything that you can talk about, money is the key feature to this. Do you know if there's been a return on investment study since the EPA is about finished with this cycle?
Well, they're still working on improving it, and there's like research going on with like how they can reduce the costs. I think that one major thing is the fact that the drinking water isn't as much of a concern now. They're trying to find, if they had to like divert the drinking water, I remember I saw that would be like $20 million to do that. So this is a cheaper and more effective, like long-term solution for this.
What are other, like, I guess, more well-known places that, like, the Superfund has been applied, in a sense, like, whether it be in North Carolina or also just across the country?
So there are multiple like Superfund sites across North Carolina and across the country. I know that Ord Mine is actually one of the biggest and most like toxic ones, I believe. I'm not fully sure where other ones are. I know places where there are like nuclear energy sites, those are Superfund sites as well because of the waste that is deposited.
There are an insane number of
Yeah, there's a lot.
Get online.
You'll be surprised if you look it up and you can see that there's like ones very close to home.
Didn't we just have some coal ash spills recently in the?
Dan River, yeah, and Dan River, they had some issues there.
And there's like the Sharon Harris plant, which I believe the waste from that causes a Superfund site.
I think Crabtree Creek, not too far from here, has been a Superfund too.
I'm assuming for like the indicator species, you didn't just like check the whole pond or the river. So like, how exactly did you sample it?
So for each, you like divide like I think it's 10 meters of the river, and throughout that 10 meters, you just like everyone, you have multiple people going around, picking up from rocks, picking up from everything. So you can kind of use that 10 meters as kind of it's supposed to be representative of other parts of the river as well, and we try to specifically choose it so that it's more
So
representative.
then the 10 meters like a proportion for the length of the river, or is it just?
No, we tried to choose like, for instance, like a riffle of the river, and that oftentimes if you choose a riffle from like each river, it's more representative.
Because you know where the macroverts are going to be like staying mostly.
And we also tried to pick a place that was not disturbed. So like if we walk somewhere in the water, we make sure not to get our species from there.
You try to do it upstream rather than downstream.
Yeah.
Because like walking, might affect the downstream.
There's a question over there?
Is StreamX your control, and if, in that case, where is that data from?
So StreamX, that was along Ornog Branch. So that was kind of like just part of Ornog Branch. It was I don't believe we used the data because it wasn't that much different from Ornog Branch itself.
Well, no, the StreamX was like a little tiny stream feeding into it. It was just like the purest water we could find. So that, yeah, it was kind of like a control. So that showed us more like for water chemistry what the perfect stream would be looking for. And Pea Creek was obviously much closer to that than Ornog Branch was. So yeah, that was kind of like a control.
Any other questions?
Available, but like the rest of you guys are screwed.
Questions, comments?